going to be talking about least common denominators, which is usually abbreviated by LCD. Least common denominators are very, very similar to least common multiples, which is abbreviated by LCM. Now, I don't usually do this, but the first thing I want to do is talk about mistakes which a lot of students make. When they want to find the LCM of 4 and 6, now they all know that L means least. A lot of students will say 2 because 2 goes into 4 evenly and 2 goes into 6 evenly. And that's the least number. But that's wrong. Not only is doing it the way I'm showing wrong, but your answer is also wrong because 1 goes into 4. 1 goes into 6 evenly. So if you're going to find the smallest number that goes into 1 and 6, it's 1. In fact, whenever you find the LCM this way, I mean for that to be 32. Whenever you find the LCM this way, which again is the wrong way, a lot of students once again will say 2 because 2 does go into 8 and 2 also goes into 32. Just for the record, 4 goes into 8 and 4 also goes into 32. And 8 even goes into both of these numbers. So why do you pick 2? Because it's the smallest number. Nonsense. 8 divided by 1, that is 1 goes into 8 and evenly, and 1 goes into 32 evenly. So not only are you doing it wrong, you're making a mistake when you do it. It turns out, using this wrong method, the smallest number that goes into A and B is always 1. Why? Because 1 goes into A times, and 1 goes into B times. For any integers A and B, it's always 1. Now, if you think, now this is why I'm telling you about this error. If you think the answer is always 1, then there'll be no reason to even talk about the least common multiple. Why? It's always 1. What your teacher says, what's the LCM of? You immediately say 1. It doesn't matter what two numbers, because 1's the least number that goes into both of them. Okay, so hopefully you won't make this mistake anymore, because you realize that you're even making a mistake with your mistake, hopefully, and you'll say, hey, the answer is always 1. Why would I be learning this if the answer is always 1? Maybe I'm doing it wrong. Now, the key thing here is it's the least common multiple. Actually, there shouldn't be an S. It's the least common multiple. Multiple is like multiply. If you're not multiplying, you're most probably doing it wrong. The LCM of 4 and 6, you need to multiply. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. 6. 6 times 1 times 2 times 3 times 4 times 5. Oh, look at this. 24 is a common multiple. But 12 is the least common multiple. is always getting larger. Never get an answer smaller than both of those numbers. And if you're going to do it wrong, please say it's 1. Don't say it's 2, because there's a smaller number than 2 that goes into both of them. Okay, so let us do a least common denominator problem. If you were asked to find the LCD for, those brackets mean 4, 7 over 6 plus, say, 2 over 9. This is the same as finding the LCM of the two denominators. Okay, it's the same as finding the LCM of the two denominators. If they're 6 and 9, you want to find the LCD of 6 and 9. And one way of doing that is to write down their times table. There's no need to say 6 times 0. Start with 1. 6, 12, 18, 24, 30, 36, 9, 18. You can stop once you realize you have the least number in common. I'm not going to debate that 36 is not on both lists, but 18 is the smallest. So the least common denominator for this sum is going to be 18. It's exactly the same as finding the LCM of the denominators. There's absolutely no difference between the two. If you were asked to find the LCD of, say, 71 over 14 plus 11 over 42, find the least common multiple of the two denominators. Let's do that up here. And you have to know your times table. 14 times 1, 14 times 2, 14 times 3, 42. That's going to be the first number on the 42 table. You will find another common number. And you will find another common number. And you'll find common multiples all day long. But 42 is going to be the least. Why can't these numbers be least? Because the 42 table grows. This number has no prayer. If this is 42 times 1, 42 times this number bigger than 1 will be more than 42. This number is on the 14 table. It's 14 times 3. That's going to be 14 times more than 3. You see, 14, it got bigger, 28, it got bigger, the 42, it got larger, it got larger, it got larger. It keeps getting larger. Okay, so 42 is going to be the least common multiple. That is, the LCD of these two fractions is 42. Let us try another one. Now, let's look at 14 and 42 again. An alternative way, rather than using the multiplication table, and lots of students don't know the 14 table, even less know the 42 table. Well, if we find the factor tree, or the prime factorization of 14 and 42 using factor trees, like 14 is 2 times 7, both of those are prime, and 42 is 7 times 6, 7 is prime, 6 reduces to 3 times 2, so we have 3 times 2 times 7. The distinct primes are 2, 3, and 7. The largest power on the 2 is 1. The largest powers on the 7 is 1. And the largest powers on the 3 is 1. So the LCM is just that product. 6 times 7 is 42. Another way of finding the LCM of 14 and 42 is to use the factor tree. We'll do some more using the multiplication tables and the factor trees. Suppose you had the LCD of, or you were asked to find the LCD of 7 over 300 plus 11 over 90. Whatever that is, it's going to be the LCM of these two numbers. So you can look at the 90 table. 90, 180, 270, 360, 450, 540, 630, 720, 810, 900, 810, 900, 990, 1080, 1170, 1260, 1350, 1440, 1530, 1620, 1710, 1800, 1890, we're getting there. 1980, 2070, 2160, 2250, 2340, 2430, 2520, 2610, and we'll stop at 2700. The 300 table. 300, 600, 900, 12, 1500, 2400. Let me try that again. 1500. The next one is 1800, then 2100, then 2400, and then 2700. This list has less numbers. It's 300s on this list, but it's not on that list. It went right past it. 600 went right past it. 900, oh, I guess I blew that one. 900 is the first one. To be honest, I thought it was 2700. I apologize. 900, that's the smallest one. Okay. Now, even if you didn't write all of this, you still had to go a little ways. Now, in theory, it could have been that long list. But the factor trees will never be that big. 300, you know, it's 100 times 3. It's 60 times 5, 10 times 30, 30 times 10, whatever. 30, you can say is 5 times 6, 10 times 3, whatever you like. 5 is prime, 6 is not. It's 2 times 3. 10 is not prime, it's 5 times 2. Okay, so 300 is 2 squared, because I had 2 2's, times the 1 3, times the 2 5's. Now 90, that's 10 times 9. 10 is 2 times 5, both of which happen to be prime. 9 is 3 times 3. So the prime factorization of 90 is 2 times 3 squared, because I have 2 of them, times 5. Now, how do you find the LCM using the factor trees? What is the LCM of 390? Well, the different primes are 2, 3, and 5. They all had the same primes, 2, 3, and 5. Put the ones if there are no powers. With respect to the powers of 2, the largest one is 2. With respect to the powers of 3, the largest one is 2. Look at this. With respect to 5, the largest one was 2. So the LCM will be 4 times 9 times 25. Now, definitely don't run to get a calculator because it takes too long. Because this is easy. 25 times 4 is 100, times 9 is 900. The same answer we got using the times table. With the time table, the numbers we use get bigger and bigger. With the factor trees, the numbers keep getting smaller. The numbers are getting smaller. Okay, 30 and 10, much smaller than 300. 9 and 10, smaller than 90. The numbers below get even smaller. So here are two ways of doing this. We can use the factor trees, or you can use least common multiples. Least common multiples. That is a times table. If you want to find the LCD of 31 over 1575 plus 13 over 490. That is, you want to find the least common multiple of those denominators. Trust me, you don't want to write down the times table. You don't want to write down the times table. So, let's look at 1575. Now you can say 5 goes into it. 5 goes into 1500 300 times, and 5 goes into 75 15 times. So 315. If you didn't know that, not a big deal. Do the long division. 5 into 15 goes 3 times. Subtract, get 0, bring down to 7. 5 into 7 goes no times. Bring down, or 0 times, excuse me, bring down. 5 goes into 7 1 time, excuse me. 5 goes into 7 1 time. Take away the 1 5. Bring down the 5. 5 into 25 goes 5 times. Okay, this 5 is prime. 5 goes into this number. 5 goes into 360 times, and 5 goes into 15 3 times. You need to do that longhand? Fine. Bring down the 5. 5 into 15 goes 3 times. This number is 7 times 9, or 21 times 3. 7 is prime just like 5, and 9 is 3 times 3. So let me get rid of my side work. So what we have is that 1575 is 3 times 3 times 5 times 5 times 7. Okay, it is what it is. 490. Well, that's 49 times 10. 49 is 7 times 7. And 10 is 5 times 2. So the prime fact, and these are the primes. The prime factorization is 2 times 5 times 7 times 7, which is 7 squared. So the LCM of 1575 and 490, well, they have, there's 2 as a prime, there's 3 being used as a prime, there's 5 being used as a prime, and 7. Those are the 4 different prime numbers that you see here and here. Okay, 2. I don't see any power of 2 here, so let me put the 1s first. And I see a power of 1 there. That's the largest power of 2 that I see, 1. When it comes to 3, I only see 1 power of 3, 2. Because I don't see any powers of 3 here. So the largest power I see is 2. What's the largest power of 5 you see? Well, you see 2 powers of 5, and 2 is the largest. When it comes to 7, you also see 2 powers of 7. I picked the largest one. So this is 2 times 9 times 25 times 35. And you can multiply this. 35 times 2, that's 70. But 70 times 9 is like 7 times 9 is 63 with a 0. Times 25. Times 25. So we'll work that out. 63 times 25, 0, 1531, and 1260 is 15750. Okay, that is the least common multiple. 15,750. That is the LCD of these 2 fractions equals the LCM of these numbers, which is 15,750. Let us try yet another one. Suppose you want to find the least common denominator of the sum of 3 fractions or difference. 1 over 9 minus 1 over 21 plus 1 over 14. This is going to be the same as the LCM of 9, 21, and 14. Now, again, you can look at the times table, or you can use the factor trees. The numbers are relatively small. Use the factor trees. If they're a bit bigger, don't. Let's find the LCM of 21 and 14. 21, 42. 14, 28, 42. Okay, so notice that these are going to repeat multiples of 42. For example, 63, 84, 56, 70, 84. They're only going to have multiples of 42. You get 105, 126, 98, 112, 126. 126. Notice, every 2 numbers here, every 3 numbers here repeat. Oh, and these numbers, 42, 84, and 126, they're multiples of 42. So, the only way 9 is going to match is if 42 is on the 9 table, or 84 is on the 9 table, or 126 is on the 9 table. This reduces to the LCM of 9 and 42. Well, we have the first few multiples of the 42. I circled them on the left. 42, 84, 126. Now, if you remember, how do you tell if 9 goes into a number? The digits must add up to a multiple of 9. Those digits add up to 6. Those add up to 12, not a multiple of 9. Look at this. That adds up to 9, a multiple of 9. That is, 9 goes into that. 9, 18, 27, 36, 45, 54. Still none of those numbers appeared. 63, 72, 81, 90, 98, 107. Sorry, after 90 I messed up. 90, then 99, then 108, then 117, and 126. This is the number that's on all 3 lists. Okay, if you wanted to find out only see, it turned out it didn't matter in this case because we already listed 126 already. But what if it was going to be, let me think, 168, 210, 252, 294. I only wrote down a handful of numbers on their 42 table. But remember, numbers on the 42 table for 14, they come up after 3. That is, I wrote 1, 2, 3, 4, 5, 6, 7. 7 times 3 is 21. I would have had it written down 1, 2, 3, 21 numbers, 7 threes. 14 numbers with the 21. Okay. But those numbers are not that small. Sorry, yeah, they're not that small. I would use factor trees. The digits are less than 10. Maybe if the denominators are less than 10, less than 12, maybe you use their times table. Look for the first common one. Okay, so we just found out that the answer is 126. Factor trees, 9. Let me rewrite that. 9 is 3 times 3. Not hard at all. 3 squared. 21, not bad either. It's 7 times 3, done. 14, 2 times 7. 2 times 7. So the LCM of 9, 21, and 14. Well, the different primes I see in order are 2. I see 3s. And I see 7s. I would underline the numbers just so you don't accidentally skip one number. Then we play the highest power we see rule. Put the 1s down. The largest power of 2 that I see here, here, or here is the only power I see, 1. When it comes to 3, I see a power there and a power there. I just put down the largest power. When it comes to 7, I see 2 powers of 7. I put down the largest one. So it's 2 times 9 times 7. 2 times 7 is 14 times 9 is 126. Exactly what we said the answer was. And in my opinion, we did an awful lot less work. Use the factor trees if the numbers are big. Let me just do one more. What is the least what is the least common denominator of 1/3 minus 1/4 plus 1/5? These numbers are small. They're single digit numbers. I might use the times table here. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 4, 8, 12. But we know the number has, the common number that's going to be in all three lists has to end in a 0 or a 5, because every number on the 5 table ends in a 0 or a 5. So it's not going to be 12. That is, 12 is not going to be on the 5 table. Okay, so we have 16, 20, 24, 28. Well, they both didn't have 20. They both don't have 30. That was a shame. 36, 40. These two lists do not both have 40, but maybe 50. 44, 48. This one doesn't have 50. 56, 60. Maybe this has 60. 45, 48, 51, 54, 57, 60. And I know eventually the 5 table will have 60, because the 5 times table has every number that ends in 5 or 0. It has every number. So 60 is the answer. It's 60. You know, apparently, even with small numbers, if you have 3 of them, this seems to be a pain. 3 is just 3 to the 1. 4 is 2 squared. 5 is just 5 to the 1. The different bases I see are 2, 3, and 5. The largest power of 2 that I see is 2, 1, and 1. 4 times 12 times 5. Well, 4 times 5, that's like 2. It's 20. And 2 times 12. Okay, I know why I put the 12. I already did 4 times 3 in my head. 4 times 3 is 12. And 12 times 5 is 60. Got the same answer, lot less work. Just to show you that I'm not crazy when I say if the numbers are small, it's not that bad. Suppose you had this. That is, you want to find the LCM of the 2 denominators. This 3 table, the 5 table. Just find this multiple of 3 that ends in a 5 or a 0, and that's the answer. Or the first one that ends in a 5 or a 0. Because the 5 table has every number that ends in a 5 or a 0. That's one way of doing it. It wasn't bad. The other way is saying that 3 is 3 to the 1. And 5 is prime, is 5 to the 1. So the LCM of 3 and 5 will be, well, the different bases are 3 and 5. 3 and 5. And the largest powers that I see are 1. So it's 3 times 5, or 15. You get to decide if you want to use the multiplication table or if you want to use the factorization of the numbers. Usually when you find the prime factorization of 2 numbers or 3 numbers, you use the factor tree. Okay, the factor tree helps you decide what the prime factorization is, but you need to write it down. Okay, next section we'll talk about how you add fractions with unlike denominators.